Hello, good morning, good afternoon, everyone. Welcome to this webinar organized by UNED within the framework of the SUTI project. Thank you very much for joining us today. In this session, we will focus on smart greenhouse management and integrated IoT platform. This is a topic highly relevant for the future of topics such as precision agriculture, sustainability, and in general digital transformation in agricultural environments. In this webinar, it is my real pleasure to introduce today's speaker, Carlos Rejón. Carlos is a professor and researcher in the Electrical and Computer Department at the Industrial Engineering School of UNED. UNED is the National University for Distance Education in Spain. And well, Carlos is an industrial electronic engineer from UNED, and he also holds a master's degree in Internet of Things. So he's really an expert on these topics. And currently he's pursuing his PhD in the field of precision agriculture with a particular focus on the use of soft sensors. During today's webinar, Carlos will share his work and insights on how IoT based platforms can support smarter, more efficient, and more sustainable greenhouse management. His presentation will help us to better understand how data, sensors, connectivity, and intelligent systems can be integrated to improve decision making in agricultural production. Carlos, thank you very much for being with us today. And well, the floor is yours.
Hello everyone, my name is Carlos Rejón. I'm professor at the National University of Distance Education in Spain, and today I'm excited to show you our project for a smart greenhouse management with an integrated Internet of Things platform. Our focus is specifically on the southeast of Spain, a region with the highest concentration of greenhouses in Europe. And while places like Almeria are agricultural powerhouses, most farms are small, family-owned operations that lack the heavy technological investments in Northern Europe. This is usually due to high cost. So our goal was to create a low-cost open source platform that allows these farmers to monitor their crops in real time, automate irrigation, and control the climate without needing a massive budget. So by using open hardware and software, we are proving that high-tech farming can be accessible, helping to save water, reduce fertilizers, and ultimately increase productivity in a sustainable way. So let's dive into the architecture. We decided to move away from the purely cloud-based systems and instead adopted the edge computing paradigm. In a traditional setup, if the internet goes down, the greenhouse stops working. In our system, the intelligence stays at the edge, meaning right there in the greenhouse. And this reduces latency and saves bandwidth because we are not sending every single bit of data to the cloud constantly. We process the critical control logic locally. So safety is another pillar of this platform since we are using the internet as a communication channel. We've implemented several layers of security. This includes WPA2 encryption for the Wi-Fi network, strict user authentication for the MQTT broker, and even disable remote SSH access to the gateway to prevent unauthorized takeovers. It's a robust system designed to behave as a single and distributed computed unit. Now let's look at the eyes and ears of the system, the IoT nodes. We use the ESP8266. It's a low-cost microcontroller that's become a favorite in the IoT community because of its integrated Wi-Fi and low power consumption. We deployed this node in four key areas. The first one is in the interior to track air temperature, humidity, and soil moisture using capacitive sensors that don't corrode over time. Another at the exterior to monitor ambient conditions and detect if a door is left open, which is a simple but vital factor for climate efficiency. In the water tank, where we monitor water temperature and control the irrigation pump. And the last one, the climatizer, a node dedicated to managing the fans, heaters, and cooling system. All these nodes communicate using the MQTT protocol, which is incredibly lightweight. They send data in JSON format, making the system highly scalable. You could add dozens of more nodes without over complicating the network. The true heart of the local operation is the gateway, powered by a Raspberry Pi 3. This device does three major things. First, it creates an ad hoc Wi-Fi network that all the nodes connected to, ensuring that I have a dedicated channel to talk. And the second, it runs Mosquito MQTT broker, which acts as the traffic cop for all incoming and outgoing messages. The third, most important, it hosts the control algorithms writing in Python by keeping the irrigation and climate logic on the Raspberry Pi. The system can react instantly to changes. For example, if the soil moisture drops below 20%, the gateway trigger the pump for a few seconds. The farmer has put in a control point. No cloud connection is required. For local monitoring, we have a Node Read dashboard accessible via any smartphone on the local network. While the local gateway handles the now, the cloud services handle the history. We use Docker containers to simulate a private cloud environment, which makes the software incredibly easy to deploy or move to a different server. For storage, we choose InfluxDB, a database specifically optimized for time series data. Every sensor reading and every actuator movement is time stamped and saved. This is where the Dash and Plotly web applications come in. It's not just a pretty interface, it's a powerful analytical tool. Farmers can see interactive graphs, check statistical summaries like standard deviations or quartiles, even calculate the energy cost of running their heater or fans based on different hourly rates. This data is crucial for long-term planning, like deciding if a solar panel installation will be a good investment for the farm or not. To conclude, this project successfully demonstrates that we can build a professional grade and secure and highly functional IoT platform using only open source tools. We have achieved full telemetry and automatic control and remote management while keeping costs to a minimum. Looking forward, the architecture is ready for Industry 4.0. It's scalable and secure. It provides the small data insights that farmers actually need to make their daily operation more efficiency. By bridging the gap between traditional agriculture and the digital world, we are just saving resources. We are helping to ensure the economic future of family-owned farms in a globalized market. Thank you for your time.
Thank you very much, Carlos, for your excellent presentation and for sharing your knowledge and research with us. Today's webinar has given us a very interesting perspective on the role of IoT technologies in smart greenhouse management and on how integrated platforms and soft sensors can contribute to the development of more efficient and sustainable precision agriculture. I would also like to thank all the participants for attending and for your interest in this session organized by UNED within the SUTI project. And well, we hope you found the webinar useful and inspiring. And thank you again for joining us, and we look forward to seeing you in future SUTI project activities. Have a great day. Bye.